Hello, today we're going to be talking still line structures, but we are going to include alkynes this time. So we know alkynes, we have a triple bond, right? Alkyne. And this carbon is sp hybridized, and that is also sp hybridized. Because of that, we need to remember that the bond angle here is 180, and that will be important when we draw line structures. If we remember before, we did alkanes, and this is butane, and here all the carbons are sp3 hybridized. And if you think about methane, here you have hydrogen, another hydrogen, right? So that is sp3 hybridized, and here the angles are 109.5. So when we draw a zigzag, we're kind of keeping the angles right. And we can also do the zigzag if we draw an alkene. And we know the alkene, here the angle should be 120. And as an example, say that we have acetone. Here, the central carbon is sp2 hybridized, which means that the geometry about this central carbon, which say includes, let's draw a plane that would include the oxygen, this carbon, and this carbon. So in the geometry here is trigonal planar. Right, so, again, the angles here at 120, and we can still draw the zigzag when we're doing alkenes. Now, but when you have an alkyne, remember, if this is sp hybridized, then we need to keep this geometry in a line, so we cannot do a zigzag. Now, that example, we can also draw another constitutional isomer. Here you have carbon 1, 2, 3, and 4. So I'm going to do a terminal alkyne. And again, this is a carbon 1, 2, 3, and 4. Right. Now we have here, notice that the geometry here, I kept the line. Here there is a hydrogen that we're not drawing. Remember that we do not draw hydrogens that are attached to a carbon. So here there is a hydrogen, but I'm not drawing it. And so here, this is sp3. Here I can bend the line. I can do my zigzag, but this part needs to be kept linear. And let's do one more example. So all of that is 180. And now let's consider another molecule. Say that I have CH2, see that. Now in this molecule particularly, notice that the carbon in the center is forming a double bond to the side and a double bond to the other carbon. So we can make another drawing showing the orbitals. So the carbon in the center is sp hybridized, and this is sp2, and this is sp2. So let's make a picture with the orbitals now. So let's choose the line that show sigma bonds. And now the central carbon here is using one of the sp hybridized orbital, another sp hybridized. So it has here one p orbital unhybridized, and it's going to make a pi bond over here. And it also has perpendicular to this p unhybridized orbital, it will have another that's making a double bond here. So notice that then the geometry here is 100, is linear. The angle here needs to be kept at 180 degree. We have all these say bonds. Now, for the geometry of the molecule overall, it's not linear because here we have the hydrogens. but the central part here is in a line. Now, notice that I have drawn here the hydrogens on dash and wedge, and it is because here we are considering the plane perpendicular to the board here. So if the pi bond is here, the bonds with the hydrogens are in the plane perpendicular. Now here for the other part, the double bond, say, is in this plane. Now the hydrogens are here in the plane of the board. And so now that will be all for that. So please pay attention to what is the hybridization, and if you can use the zigzag line, or if you need to keep this, say, in a line if you have an sp carbon. So we must pay attention to hybridization. So that's all for now.